So good morning, all of you.
Good morning, ma'am.
Yes, good
Good
morning.
morning,
Good
ma'am.
morning, ma'am.
Very good morning, ma'am.
Yeah, good morning to all. So hope all of you are safe.
Yes,
Yes, ma'am.
ma'am.
Yeah, and because day by day numbers are increasing. So I think I have to start with the new chapter. So now we are towards the completion of our syllabus. ठीक? So इसके बाद दो छोटे छोटे chapters रहेंगे. So probably by 25th January or in the end by the end of January, we will be in a condition to complete our syllabus. We'll get some time for reading also,
Yes, ma'am.
right? So well, the next chapter is acoustics and ultrasonic waves. Fine, it's a very small chapter, and there are few things that you have already studied. Acoustics में तो कैसा है कि means you'll be it will be a kind of revision only. Okay, जो आप लोग आगे पढ़ के आए हो थोड़ा वो है, and then we'll be going for some acoustical materials and Sabines formula which we don't have to derive. पहले derivation था, but now we don't have the derivation. So छोटा chapter है in short. 10 marks for both the sections, acoustics and ultrasonics, right? Now see, what is this acoustics? It is the sound engineering of auditorium. Acoustical engineering matlab the application of acoustics in technology. Now what is this acoustics? Actually, let me start with a simple example. Ki nowadays, we people, we used to, means if we want to go for a cinema movie, we would prefer a multiplex instead of the old traditional cinema hall, right? वो सिनेमा हॉल जो पुराने थे वहां पे हम नहीं जाते हैं. We would prefer a multiplex. Why? Because it has a good sound system. वहां की अच्छी है XYZ multiplex की. The sound system is very nice. So we would prefer going for that XYZ multiplex. Fine. क्यों why? क्यों वहाँ की sound system अच्छी है? Because it is having a good acoustics. Good acoustics मतलब कि it has a proper absorbing material, proper reflecting material. Right now, acoustics deals with the proportion of the percentage of the reflecting and the absorbing materials present inside a given cinema hall. Yeah, in a given hall, right? Because जो traditional cinema halls थे ना, वहां पे you must have seen कि proper curtain भी नहीं होती थी, right? Sometimes the flooring was also not there, right? So in the multiplexes, no, whenever it is constructed, the area of the flooring is taken care, right? Even जो curtains लगी है, तो curtains की area भी calculate करके then they used to tie the curtain, right? On the roof there are some porous material, ceramic का dot वाले. Yeah, my voice is not clear.
No, ma'am. Yes, voice is clear.
Okay, maybe someone is writing, so I think there will be a issue from your side. You check your network. Okay, so in the cinema hall, you can see there are some porous materials are there. White color का halls वाले material होते हैं, right? And that will be a double layer. ऊपर ceramic होगा and below the ceramic there will be a iron gauze, a kind of metallic gauze. Right? So क्या होगा? Sometimes if the intensity of the sound is more, no, the sound waves will fall on that material and then after it will fall, after that porous जो holes होते हैं ना छोटे छोटे pin holes जैसे, वहां से वो sound waves जो है वो iron gauze या metallic gauze के ऊपर जाएंगे and due to that the metallic gauze vibrate and it will convert the sound energy to heat energy, right? So they are a kind of absorbers. Right? So in the multiplexes, all these things are taken care. Even जो chairs होती है ना, chair total number of chairs present inside the room, फिर उसका area कितना है, because chairs are also the absorbers. Windows है, so it will be having some reflecting surfaces, right? So the area of the reflecting surfaces, audience कितने बैठने वाले हैं, right? So number of audience sitting inside the multiplexes, they are the absorbers. Audience are the absorbers, right? So based on the percentage of absorbers, the reflecting surfaces will also be kept, right? And that will give you a good sound system, right? Sometimes, no, I don't know whether you people have experienced or not. When one if we go for a movie, no, if one show is completed and when we enter for the other show, no, you may hear a kind of काम तो काय हाँ lecture चालू છે. So when you go after a show, no, you may hear sometimes of some type of vibration, some types of sound coming from the hall, right? So that will be because of the reflection. For some time you may hear the sounds, a kind of echo. Though the audio is off, you will listen to some kind of sounds, right? So that is not a case for the good acoustics. ऐसा नहीं होना चाहिए. Okay, particularly now if we go for some drama and other things on a hall, yeah, in an auditorium, you may hear a kind of vibrations coming, right? So we will go across all these points so that are not required, right? So all these things comes under acoustics. There has to be a good acoustics, right? So before constructing the multiplex, yeah, before constructing any hall, yeah, auditorium, the acoustics has to be considered, right? We'll be learning a formula which is known as a Sabines formula. So based on that Sabines formula, we will be fixing the time known as a reverberation time, and based on that, the number of the amount of, yeah, you can say that the percentage of the reflecting surface, absorbing surface, and the transmitting surface will be fixed. So that comes under acoustics, right? So what we'll be studying here is production and propagation of sound waves. How the sound, we all know, right? We have studied production of the sound waves, how the sound waves propagate, right? When the speaker speaks, there will be the air particles of the medium which will be near to the source of sound, right? So when the source of sound emits the sound waves, the particles near to the source will absorb the sound energy, right? And due to which the particle vibrates, and then after there will be the transfer of energy from one particle to other, and the sound waves propagate, right? Classification of the sound waves based on the frequency, characteristics of the sound waves, sound intensity, properties, Sabine's formula for reverberation time. This is an important formula. Yeah, reverberation time is an important factor that affects the acoustics. Whenever the auditoriums and yeah, you can say that multiplexes or cinema halls are constructed, the reverberation time is considered. Then after, the factors affecting the acoustics of building, right? These are the few topics that we'll be studying in the first part, acoustics. Second part will be the ultrasonic waves. So how the sound waves are produced, right? As I told you, there is a transfer of energy from one particle to the other particle, and the sound waves propagate by the compression and rarefaction, right? The sound waves propagate by compression and rarefaction. So this is just for your information that we can listen 10 to the power minus 16 sound intensity, which is known as an threshold of audibility. This is a minimum intensity that an human ear can hear. This also you have studied. Now, classification of the sound waves. There are three types of sound waves: infrasonic waves, audible waves, and ultrasonic waves. Ultrasonic will be studied. Infrasonic are the waves between 1 to 17 hertz frequency. In some books, it is written 1 to 20 hertz, and then 20 to 20 kilohertz for the audible waves. And for the ultrasonic waves, it is greater than the 20 kilohertz, right? I think this also you have studied. When these infrasonic waves are produced, can anyone tell me? When these infrasonic waves are produced? In earthquake, okay. And ultrasonic?
By bats.
By bats, okay. Fine. So, just what is the range of frequency for the ultrasonic waves and the audible waves? Change क्यों नहीं? Right. So classification of waves, this also you have studied. Two types of waves are there: transverse waves and the longitudinal waves. What are the transverse waves? The displacement of the particle is at a right angle to the direction of the propagation of waves. Suppose if this is the direction of the propagation of waves, the displacement of the particle will be perpendicular, right? In this manner. The displacement of a particle is perpendicular to the direction of the propagation. Right? Wave particle will vibrate in up and
Your
down.
voice is
direction.
coming.
Not coming?
No, ma'am, it's clear.
Yes, ma'am. Now it.
Okay, fine. It's okay. So what is the transverse waves? The particle will vibrate perpendicular to the direction of the propagation, right? And can you give me the example of the transverse waves?
Light.
Can anyone? Sorry? Light waves. Any other example? Yes, electromagnetic waves, right. Right? So then after, the next is the longitudinal waves. The displacement is in the same direction as the waves propagate, right? In the case of the longitudinal waves, suppose if this is the direction of the propagation, the displacement of the particle will be along the x-axis only, in the same direction of the propagation, right? So this is how the sound waves propagate in the form of compression and rarefaction, right? Wave particle vibrate to and fro along the path the wave travels. So इसमें कुछ समझाने वाली बात नहीं, right? You all of you मतलब ये थोड़ा बहुत तो आप पढ़ चुके हो. So there are two types of waves, the transverse waves and the longitudinal waves. In the case of the transverse waves, the displacement of the particle are perpendicular, and in the case of the longitudinal waves, it is along the same direction in which the waves travel, right? So there is a transfer of energy without transferring the matter. The characteristics of the sound waves. So the three important characteristics of the sound wave: pitch, timbre, and loudness. Now, what is this pitch? Pitch is related to the frequency, right? By the way, means this pitch and timbre, and one more is that note, N-O-T-E, note. These are the characteristics that are used by the music directors, right? You must have seen whenever any song is composed, no, a fellow used to stand with a stick, और वो स्टिक ऐसे ऊपर नीचे ऐसे करते, राइट? मींस इंक्रीज द पिच, डिक्रीज द पिच, मीडियम पिच, ऐसे कुछ सिंबल्स होते हैं, राइट? सो पिच इज रिलेटेड टू द फ्रीक्वेंसी. हाई पिच साउंड, a low pitch sound, right? High pitch sound means a sound with a very high frequency. Low pitch means a sound with a low frequency. Say for example, the sound waves emitted by the girls, right? A shrill sound. If I say high pitch sound is a shrill sound, okay, a very high frequency. Flat sound is a low pitch sound, okay. The sound waves produced by the boys, right? These are the best examples. So a high pitch, a shrill sound, low pitch, a flat sound, okay. Then after, timbre. Timbre gives the quality of the sound waves that are produced. See, sometimes what happens, if a song is sung with the same frequency, matlab with the same pitch, with the same loudness, the note is also same, but the timbre may vary. It gives the quality. Say if a song sung by XYZ singer, a very famous singer, right? And the same song with the same pitch, same loudness, sung by some ordinary fellow. Okay, so that the quality of the sound will vary. So timbre gives the quality of the sound. Yeah, timbre determines the quality of the sounds, right? So I gave you the example. कि कोई singer अगर song, if a singer is singing a song and the same song is sung by some other fellow who is not a singer, okay, with the same pitch, वही frequency से, वही loudness से वो song गा रहा है, okay, then also you can see the difference in the quality of the sound. So timbre gives the quality. Note is not there in our syllabus. ये तीन characteristics ही रखी है हमने. Loudness. Third characteristics is loudness. Now loudness varies from person to person, and it also depends upon the distance. Say for example, a sound produced or a sound heard by X fellow will not be of the same loudness that is heard by Y. Okay, if his ear is not proper, it depends on the sensation of the eardrum. Okay, similarly, a sound wave heard by a fellow who is sitting near the source will not be same as that of fellow who is listening to a sound wave which is sound who is sitting in some other room, right? So it also depends on the distance, because when the sound waves propagates, उसके जो amplitude है वो decrease होता जाता है, right? With respect to distance, the intensity of the sound goes on decreasing, right? So the loudness will depend upon the sensitivity of the eardrum and also distance between the source and the listener, right? So a pitch, it depends on frequency. High frequency means high pitch sound. Low frequency means low pitch sound. Timbre, it gives the quality of the sound, right? And loudness, it is a psychological sensation. It is determined by its intensity, right? And this we have already seen, the lower intensity that a human ear can hear. Yeah, human ear can listen, right? It also depends on the distance, okay? Sensitivity of the eardrum, okay? And how alert you are, okay? So is it fine till this point what we have seen, how the sound waves propagate? Three characteristics of the sound waves: pitch, timbre, and loudness. Okay, and two types of sound waves. That is the longitudinal and the transverse sound waves. So is it fine till this point?
Yes, ma'am.
Yes, ma'am.
Yeah. So we can move further now. आगे जाए थोड़ा. हाँ. The loudness measurement. The main thing is this formula, okay, that we'll be using in numericals. L is equal to 10 log I1 by I0. Now let us assume L be the loudness. Let us say that I is the intensity. Okay, so let L0 be our reference loudness and its intensity is I0, right? So it is told that loudness is the logarithmic of the intensity. So L0 is equal to log I0, right? उसी तरह with reference to this reference loudness, let us consider another sound whose loudness is L1, another sound waves whose loudness is L1 and intensity is I0. So as per the formula, I can write L1 is equal to log I1, right? Loudness is the logarithmic of intensity. So this is my reference loudness and this is the loudness that I wanted to measure. Yeah, this is the, you can say the loudness of the sound produced by some other source, right? So if I just simplify it, if I take the difference, what is the difference in the loudness? L1 minus L0, let it be L. So what I can write log I1 minus log I0, which can be written as log I1 upon I0. Now see, in this case, the unit of loudness is bell. Okay, but bell is a very large unit and bell cannot be listened by the human ear. It will be a very large intensity. Fine. So what we will do, we will convert it to decibel. So L is equal to 10 log I1 upon I0 in decibel. You might have studied that the loudness is measured in decibel. Sound is measured in decibel. Bell तो बहुत बड़ा unit हो जाएगा and our eardrum cannot bear that loud sound, right? So it is, we can hear in the range of we can hear the sound waves in the range of decibel only, right? So I am converting it to decibel. So L is equal to 10 log I1 upon I0 decibel, right? Now let us say that, let us assume कि I1 is 10 times than that of the reference intensity. I1 is 10 I0, let us say. Okay, so what I can write, L is equal to 10 log 10 I0 by I0 decibel. So that will be equal to 10 decibel. उसी तरह 100 decibel. Let us say I1 is 100 times than that of the absolute intensity. So my loudness will be 10 log 100 I0 by I0. So that will be equal to 10 log 10 square decibel. So 20 log, that will be 20 decibel. उसी तरह 1000 times है तो 30 decibel. Okay, इसी तरह integer में it will go on increasing. Right, we will solve this sum by the way. Okay, ये एक अलग sum के form में ही आता है, so that we will solve later on. But this is what we want, the formula of the loudness, right? L is equal to 10 log I1 by I0. Yeah, sometimes I1, I2 by I1, right? Derivation is not there, just you need to remember the equation. These are the different intensity levels for different types of materials. No need of remembering. I have just listed for your reference, right? Audibility threshold is 10 to the power minus 12 in MKs. So in that case, the level of intensity will be 0, greater, matlab number of times greater than the threshold, it's fine. Rustling leaves, 10 to the power minus 11. So level of intensity is 10. And how many times it is greater than the threshold of audibility? 10 to the power 1. उसी तरह the different types of sound waves are given and how it is greater than the reference intensity. You can just have a look afterwards. Okay. Few of the properties that are exhibited by the sound waves. Sound waves can be reflected, it can be absorbed, it can be transmitted, interference भी होगा, diffraction भी होगा, right? See, whenever the sound waves are emitted, they fall on the surface, right? Sound waves travel and then after they fall on the surface. Now, whenever the sound waves fall on any surface, there are three possibilities. It can be reflected depending on the surface. There is a possibility of reflection. There is a possibility of absorption. It can also be absorbed, and the sound waves can also be transmitted. Okay, depending upon the surface. These are the three possibilities whenever the sound waves fall on the surface, right? So based on that, let us move on to the first thing, reflection. Okay, now whenever the sound waves are reflected, there are two possibilities. There can be a reverberation and echo. Echo, all of you know. What is echo? And when the echo is produced? Can anyone tell what is echo? Maths नहीं करना है हाँ?
Ma'am, when 17 more than 17 meters of distance are there between the
Okay.
source and reflector,
हाँ.
then sound. Uh,
There is reflection of sound waves.
yes, ma'am.
Okay. If the distance is more than 17 meter and the sound waves are reflected, we tell it as a echo. Now, what is the reverberation? Reverberation is a reflection of the sound waves in a closed room, in a closed environment, right? Matlab it is less than 17 meter. So it is told that the persistence of the sound waves after the source of sound is switched off, that phenomena is known as reverberation. Okay, जो मैंने एग्जांपल दिया था आपको सिनेमा हॉल वाला, स्क्रीन पे कुछ भी नहीं आ रहा है, but then also you have a sensation, you can listen to the sound waves. Okay, उसी तरह अभी तो अंडरपास सब खुले हो गए, but ट्रेन ऊपर से जा रही है, right? So even though the train is passed, if you are there in the underpass, you can listen to sometimes the sound of the train. Okay, so that is a reverberation. Though it is a closed, open space, but the two sides will be closed, right? So for some time, you can listen what tak 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 आवाज आती है, right? Even in a closed room or in an auditorium also, after an event is over, if there is no proper acoustics, you can listen to some of the sound waves that will fall on your eardrum, right? So that is a reverberation. Okay, the persistence of the sound waves for some time after switching off the source of sound. Source off कर दिया है, then also you listen to some type of sound waves. That is known as a reverberation. Or we can tell reverberation as a multiple echo. From the different surfaces of a room, the sound waves will be reflected. So that will create a multiple echo, right? Multiple reflections of the sound waves will be there. Sometimes it may happen that you may have a room where you don't have any reflection. Okay, and if there are no reflections in an auditorium, then you will not be able to listen to the sound waves. So that room is known as a dead room. The reflections are required up to a certain limit to get an audible sound waves. But if there are no reflections, then you will not be able to listen to the sound waves. There has to be the reflection of the sound waves once the source emits the sound waves, right? And if you don't have any reflections, we tell it as a dead room. Okay, you will not be in a dead room, no sound waves will be heard, right? So reverberation is a multiple echo, multiple reflections of the sound waves from the reflecting surfaces, the prolonged reflection of the sound from the walls, floor and ceiling of a room. Okay, because on this surfaces there will be some reflecting surface. So that reflecting surface will be reflecting the sound waves. Yeah, the persistence of the sound after the source has stopped to emit the sound. Okay, after the source is switched off, then after you will listen to the sound. So that is known as a reverberation. Uh, to some extent, it may be possible. The number of absorbing surface is to be increased. Okay, in a given room, in a given auditorium, if the number of absorbing surfaces are increased, then you can create a dead room. Okay, but the condition is the room has to be airtight. Okay, in that case, you can create a dead room. The perfect definition of reverberation is time taken by sound to reduce to 1 millionth of its original intensity just before the source is cut off. Okay, before switching off the source of sound, just before the source of sound is switched off, right? Before that, the time taken by a sound to reduce to 1 millionth of its original intensity. ये थोड़ा difficult रहेगा आपके लिए because we are not going to see the derivation. So better you can for the definition you can go for the second and the third point. Okay? Because अगर derivation लेते तो उसमें ये आ जाता जो इंटेंसिटी है वो 1 millionth होती है होने के लिए जो टाइम लगता है that time we tell as a reverberation time. Okay, so the time for which the reflected sounds are heard, that time is known as a reverberation time. Process is reverberation, but time duration for which you can listen to the reflected sound waves, that time duration we tell as the reverberation time. Then after the absorption of sound, for the absorption of sound, we would go to the absorption coefficient. I think this will be the last topic. बहुत ज़्यादा नहीं bombardment करूँगी. Okay. See, as I told you, whenever the sound waves fall on the surface, okay, some of the sound waves are reflected, some of the sound waves are absorbed, some are transmitted. Okay. So what is the absorption coefficient? It is the ratio of the sound energy absorbed by the surface to the total sound energy falling on the surface. Because ऐसा नहीं है ना जितने sound energy surface के ऊपर fall हो रही है, all the sound energy will be absorbed, या all of them will be transmitted, या all of them will be reflected. Some part will be reflected based on the surface, some part will be absorbed, some part will be transmitted. Right. So the absorption coefficient is the ratio of the sound energy falling on the surface to the total sound energy incident on the surface. Right. And the unit of absorption coefficient is Sabine. Sabine is the name of a scientist, and after his name, Sabine was given. Right. Now, if I go, even open window unit is also a unit of absorption coefficient. Now, what it says, say for example, you just assume a window whose dimension is 1 by 1. Okay, we are assuming a window with a dimension 1 by 1 unit. Okay, 1 unit length and 1 unit breadth. Now, let us say that the sound energy is falling on that open window. The window is open, right? So ideally, we can see that when the sound energy fall on that open window, we say that all the sound energy get absorbed, right? None of the sound energy is reflected, right? So when the sound energy falls on an open window, the energy absorbed, the sound energy absorbed by that window, we tell it as a 1 OWU, one open window unit. So it's a little bit logical, right? When the sound falls, as the window is open, all the sound energy will be absorbed. Yeah, all the sound energy will be transmitted. So that we tell as a open window unit. What is one open window unit, right? So this I will be taking in next class क्योंकि ये मुझे समझाना है आपको. Though there is no derivation, I will explain you how we are getting this equation. 0.161 V upon A. Okay, so that I will explain you later. But I think सब साथ में ही लूंगी. क्या टाइम हुआ है? क्या करूं? assumptions ले लूं या साथ में ही लूं? Derivation और assumption 10 मिनट है. What you want?
हम साथ में ही
हम दोनों साथ में ले लेंगे ना फिर।
ठीक है, चलो तो 10 मिनट क्या करें? तो 2-2.5 लेक्चर में ये चैप्टर कंप्लीट हो जाता है. छोटा ही है. कौन सा पेपर है आज? मैथ्स मैम.
पहले
मैथ्स. अच्छा, LA. ओके. ठीक है, कोई बात नहीं. चलो करो मैथ्स. और तो क्या